forester, and I've worked my entire professional career and had my training in the forests of New Hampshire. I was a county forester in southern New Hampshire for 16 years and have been the state's extension forester since 1996. That was the introduction. Here's the caveat. I'm on most solid ground when talking about New England and particularly New Hampshire's forests. The further away you are from these forests, the more I will rely on you to adapt my information to your particular situation. Many of my examples will be New Hampshire and New England examples. And since I'm new to this, I will answer your questions at the end of my presentation, and I promise there'll be plenty of time for question and answers. Before we start answering the questions of why trees grow where they do, let's look where they grow, and let's look big, worldwide. According to the Earth Policy Institute website, in 2010, forests covered 31% of the world's land surface, just under 10 billion acres, down from the pre-industrial area of just over 14.5 billion acres. And here is the first hint of why trees grow where they do. And no surprise, they grow or don't grow because of human activity. But much more to come on that. In the U.S., 33% of the land is covered, or 745 million acres. For landowners and foresters, we're used to characterizing forests by stands. A stand is a group of trees similar in age, structure, and species mix, and growing on a site at sufficiently similar quality to distinguish it from adjacent areas. But when we look at larger landscapes, we can characterize forests as biomes. A biome is a regional or continental scale ecosystem characterized by distinct types of vegetation, animals, and microbes that have developed under specific soil and climatic conditions. Since climate has such an influence on soil development, the vegetation with a biome largely corresponds to climate. I will revisit the topic of climate in a bit. On this U.S. map, I show where New Hampshire is situated in the eastern temperate biome, which is the green area. And hopefully you can see my pointer. So why do trees grow where they do? I plan to cover these 5 topics in more or less greater detail, but before I start, I need to make an important point. Even though I'm talking about discrete influencers of where trees grow, these influences are intertwined, add on to each other, affect each other, and the relative importance of them at a given site may be difficult to tease apart. But in summary, trees grow where they do because of 1, adaptations over time, 2, climate, 3, relationship to other trees, 4, past site history, and 5, lastly, I'll talk about inherent site capability. Every time I start a new topic, I will show you where this slide is. I will show you this slide as a reminder as to where we are in my presentation topics. Adaptations over time. Trees have been adapting to their environment since the beginning. These adaptations result in trees growing in certain geographic ranges and on certain sites within those ranges. This has set broad but very definite limits to where they grow. For example, red spruce, shown on the left, the range of it shown on the left is a northern conifer. Loblolly pine, the range of which is shown on the right, is a southern conifer. Transplant them to each other's natural range and neither species will do well or even survive for long. Trees also adapt to specific sites within their growing range. Here I have a few examples. Yellow birch, black gum, red maple, hemlock will tolerate wet soils within a given site, within a given area. Red oak, beech, sugar maple, ash prefer and are better adapted to well-drained soils. So different species are adapted to grow and thrive in different conditions. They have developed different strategies to survive. For example, on a broad scale, trees in our temperate forests have adapted to cope with 4 distinct seasons. The majority of our forest is deciduous, and trees shed their leaves to protect themselves from freezing temperatures. Northern boreal forests have evolved to deal with shorter growing seasons, with fewer deciduous trees, because they can't afford to grow all of their leaves every year. so there are more conifers in the boreal region. The trees best adapted to their sites will thrive and reproduce. And in this picture, we see white pine and hemlock growing on a very nutrient and moisture-poor site. Softwood's survival strategy is to reproduce and grow under fairly harsh conditions. That's all I wanted to say about adaptations over time. Next, I'll talk more about the effect of climate on where trees grow. Climate is the long-term weather pattern of an area, including temperature, precipitation, and wind. Climate is how weather acts over many years. It controls the amount of solar energy and water available for tree growth through temperature and precipitation. Climate affects soil development. It changes north to south and from high elevation to low elevation. Paper and black birch nicely illustrate how climate affects where tree species will grow. Black birch is pictured in the background and paper birch in the foreground. They both occupy similar soils in successional stages, though paper birch is more intolerant to shade than black birch. However, paper birch grows further north than does black birch, on growing sites that are otherwise fairly similar. It's climate that impacts where each species grows in abundance. Here we have a map of the mean annual temperature of the U.S. If we were to lay the mean annual temperature over the distribution map of southern red oak, we would see southern red oak is distributed south of where the 55 to 60 degree mean annual temperature line is. Though the distribution range of northern red oak overlaps southern red oak, in the southern end of its range, it is limited to the north by the cold temperature and roughly follows the northern limit of the 40-degree mean annual temperature. Climate changes over large areas, but also within an area depending on the elevation. At sea level, we see a 1 degree Fahrenheit change for every 100-mile change in latitude, and a 3 degree Fahrenheit change for every 1,000 feet in elevation. So with regards to changes in temperature, traveling up a hill every 300 feet in elevation is roughly equivalent to traveling 100 miles north. I expect with all this talk about climate, you would like me to say something about the effect of global climate change on where trees will grow. Logically, there will be changes. After all, 20,000 years ago, New England and much of the northern U.S. was buried under ice a mile thick. By 12,000 years ago, the glacier had melted. The first successional stage, or natural community, was tundra. 11,000 years ago, spruce woodlands were the dominant forests. Patches of trees were interspersed with tundra vegetation. This spruce forest, tundra vegetation growth coincided with the arrival of the first Native Americans. This blue line encircles the extent of the last glacial period. Remember that the glacier not only changed the trees growing in this region immediately after it receded, but also impacted soil fertility and moisture holding capacity and has a long-lasting effect on why trees grow where they do. So back to what effect climate will have on where trees grow. This series of map of the Northeast shows our current forests on the left and two suggested scenarios. Both scenarios predict a decrease in northern hardwoods, beech, birch, and maple, the pink area, and an increase in oak and hickory, the green area. When and how trees might migrate is beyond the scope of today's presentation and, frankly, my knowledge. But based on trends, we will likely see changes in temperature, rainfall patterns, longer growing seasons, drier soils in the summer, and wetter winter soils, and increases in insects and diseases. All these changes will affect where different tree species grow and where they will thrive or fail to thrive. Time to change topics. I've probably said enough about climate, so let's talk about relationship to other trees. Specifically, I'll talk about tree propagules. By that I mean seed source, sprouts, and planted seedlings. And I'll also talk about light on a specific site. Excuse me while I get a glass of water. Okay, I'm back. Some sort of regenerating propagule, seed source, sprout, or planted seedling is important because no propagule, no regeneration, no tree. The amount of light is important because light determines whether or not a tree will regenerate and grow. Aspen and willow, for example, need direct sun to germinate and grow, while white pine does better with partial sun. How much light a tree has also determines how fast it will grow. Regenerating a forest is a tricky proposition, as you know. The seed source or lack of one determines what might grow, but even if there are mature trees of seed-bearing age, there is no guarantee seedlings will result. For one thing, not every year is a good seed year for everything. There are all sorts of insects and predators such as squirrels and chipmunks that feed on seeds that are produced. Seeds are disseminated and planted naturally by wind, gravity, but also animals and birds. So animals and birds help with tree regeneration. Most seeds fall within 200 feet of the parent tree. So how do white pines get planted under oaks and oaks under white pine, a very common occurrence here in New Hampshire? The answer is that squirrels and blue jays cache seeds for the winter and don't find them all. They are de facto Johnny Appleseeds of the oak pine world. Even when viable, there are no real guarantees that the seed will fall on a congenial seed bed and have the proper amount of water and nutrients to germinate and grow. Our management can encourage desirable trees to germinate and survive. Stumps, roots, and seedling sprouting can be a way to regenerate many hardwood species and can be an important way to regenerate red maple and red oak. Aspen and beech regenerate by root suckering or cloning. Though some softwoods can sprout, this isn't a major way for these types of trees to regenerate, so seeds are the way that softwoods regenerate. And of course, in many parts of the country, planting is an important way for trees to regenerate on a site. We don't happen to do much planting in New Hampshire, relying instead on good silviculture to naturally regenerate our forest stands. Whether or not a tree is growing on a site depends on where the site is in its successional stage. Succession influences why trees grow where they do. Succession is the change in plant communities over time. As plants inhabit a site, they change it, making the site less suitable for themselves by changing light conditions, soil temperature, and the nutrient and moisture regimes. Succession isn't a neat path. It differs by site and human and natural disturbance. But we can make some predictions about what trees will occupy a site after a natural or human disturbance and what trees will follow. When there's a disturbance in the forest, such as when an area is cleared, for example, we get a group of species we consider early successional and intolerant of shade. Grasses, brambles, shrubs, cherry, gray birch, aspen, white birch, seed in, germinate, and grow. We call them intolerant because they germinate and grow well in direct sun and can't reproduce in their own shade. In time, they're followed by intermediate tolerant trees, such as white pine and red oak. As they grow a dense overstory, they can't reproduce in their own shade, and we get hemlock, beech, sugar maple, and perhaps red spruce, trees we call tolerant of shade. The specific suite of species that occupy a site depends on what trees are growing in the general area already, namely the parents of the seedlings, and also the soil type, which is the growing medium for the newly emerging seedlings. Forests are dynamic, always changing. Even if we do nothing, forests will succeed. A lot of forest management is about using these natural successional trends to our own advantage, creating the conditions to favor the species we want to grow. Understanding shade tolerance is really important to understanding why a tree is growing in an area, and also an important concept in silviculture. Tolerance is the ability of a tree to grow satisfactorily in the shade of another tree. Intolerant to shade means a tree tends not to reproduce under itself, tends to be sun-loving, tends to be light-seeded, wind-dispersed. We call them early successional species. Trees tolerant to shade reproduce under themselves, tend to be heavier seeded and moved by gravity, or animals. White birch is the poster child for intolerance. This list on this slide is a repeat of the summary of the previous slide, but worth reviewing. Intolerants can't reproduce in shade. They're usually short-lived, wind-dispersed, light-seeded. We call them early successional or pioneer species. I have a colleague who calls intolerants the rock and rollers of the tree world. They live fast, die young, and spread as much seed as possible. That's their strategy for survival. Eastern hemlock is the poster child for tolerant species. Tolerants reproduce and survive in shade for long periods, and in order to live in heavier shade, tolerants develop wide crowns to capture whatever sunlight is filtering through the upper canopy to where they're growing in the lower canopy. They wait in the lower canopy for openings in the upper canopy before they direct their energy to height growth. They can live many, many years, decades even, in the understory in that condition. Intermediates are just as the name implies. Their tolerance for shade is intermediate. By the way, intermediates can be some of the hardest trees to regenerate. After all, it is relatively easy to regenerate intolerance. Use a silvicultural technique such as a clear cut to cast as much sun on the ground as possible. For tolerance, use a technique that casts less sun on the ground and maintains more shade, such as individual tree selection. It is more difficult to satisfy the more nuanced light needs of the intermediates, and we do that through partial harvest approaches such as shelterwood and group selection, and also through timing of harvests to coincide as best as possible with good seed years, and also try to time the harvest during the time of year to maximize scarification, the mixing up of the topsoil, in order to develop a good seed bed. Here is a nice listing of tree species by their tolerance ratings. Balsam fir, eastern hemlock, American beech, and sugar maple are considered extremely tolerant. They grow in deep shade. Red spruce, white spruce, northern white cedar, and red maple tolerant. Eastern white pine, white ash, red oak, and yellow birch are intermediate. And by the way, some of these species are more valuable timber species. And as I said earlier, they're also some of our more difficult species to regenerate. Intolerant species include red pine and paper birch. Extremely intolerant, aspen. And I would add pincherry and gray birch to the extremely intolerant hardwood list as well. Here's another list rating the shade tolerance of more species. I'm not going to read them, but they are available if you download this presentation for you to refer to later. Now on to the effect that the site history has on where trees grow. And I'll start with human disturbance. This graph shows the percent forest cover for New Hampshire from 1600 to 2000. In 1600, we estimate that New Hampshire was 95% forested. We are currently about 83% forested, the second most forested state in the nation after our friends in Maine. Similar graphs exist for your state, I'm sure, and probably show a similar story. To illustrate the history of the land and its impact on forests, I'm going to show you a series of slides of dioramas from the Harvard Forest Fisher Museum in Petersham, Massachusetts, that illustrates the history of the land of central Massachusetts. In the 1700s, pre-European settlement forests, Native Americans burned forests for hunting, and they girdled and cleared them for agriculture. At least in New England, this activity was mostly along the coast and went inland along the major rivers. How extensive and long-lasting the impact of native land management activities were is dependent on where you are, and much of it was obscured by later European settlement. But prior to European settlement, forests in New England were a patch-like mosaic shaped by natural and human disturbances, site conditions, and individual tree species characteristics. From 1700 to the present, humans are the #1 disturbance factor affecting the structure and composition of our forests. This diorama depicts early clearing by settlers. Clearing progressed slowly. After all, they were using axes, oxen, and the sweat of their own brow. The best trees were used for building and the rest piled and burned to make way for agriculture. The lower slopes where the soil was likely more fertile were cleared, but hills, which likely had thinner soil from the glacier scraping and which were steeper and harder to farm, were still forested. This is the same scene as the prior pre-settlement slide. All the following slides show the same scene at different times. This is what the landscape would have looked like in 1850. 70% of the land south of the White Mountains in New Hampshire had been cleared for agriculture. Much of this clearing was motivated by the market for wool and the need for sheep pasture. In addition to changes in forest cover, wildlife populations changed. Agriculture likely altered the ability of the soil to hold minerals. We know much of the soil was eroded away. When the land was eventually abandoned, the remaining soil and ground condition encouraged the regeneration of atypical species by altering the seedbed. White pine was a major beneficiary of this past agricultural land use. Today we have pine and other softwoods growing on sites that naturally should be growing hardwoods, if not for the past agricultural use of the land. After the 1850s, there was a period of farm abandonment, and forests began to increase again as people headed for the richer farmland of the Midwest and for economic opportunities in the industrializing cities. In this diorama, you can see white pine beginning to come into upper fields and pastures, those likely abandoned first. White pine is light-seeded and grew well on the mineral soils devoid of forest leaf litter. This is the same scene around 1910. About 60 years have passed, and by now the pine was large enough to be harvested. In New England, more lumber was cut in the decade of the 19-teens than any decade before or since. That was the time when everything was built with wood. Boxes and railroad ties consumed huge quantities of timber. After the pine was cut, hardwoods took over many of these sites, since many of them were tolerant of the shade the pine cast, and they had regenerated and persisted in the understory, ready to take advantage of the light when this harvesting occurred. Other hardwoods were of the light-seeded, intolerant species, and they blew in and regenerated after the harvest. Today, as a result of this land use history, we have softwoods growing where hardwoods would have naturally grown in the absence of this history, and more of them, especially white pine. Today, these sites are succeeding to the forest type that they are more naturally suited to grow, as these agriculturally established forests are managed by humans and disturbed by nature. So let's talk about natural disturbances. Since natural disturbances influence species composition, age, and structure by killing individual trees, patches of trees, or stands of trees. I like to say that fires shape the forest of the West, but wind shapes the forest of the Northeast. No surprise when you look at the graphic in the upper right-hand corner showing the direction of prevailing winds. They all seem to land on the East Coast. The map on the bottom shows the landfalling hurricanes in the eastern U.S. from 1900 to 1996. In New Hampshire, for example, we had major forest stand replacing hurricanes in 1938, 1954, and 1955. New Hampshire also had a tornado in 2008 that sliced a 50-mile swath through our state. We have periodic and regular mini wind events, microbursts that we don't always monitor, but are evident in the woods. Wind breaks and topples trees and forests. Something else grows. Recent ice storms in 1998 and 2008 in the Northeast grabbed headlines, but they have been a regular natural disturbance in the northern forest. Fire is another natural disturbance that has influenced where and what type of tree grows. Though more controlled today, we have trees and forest types that are fire dependent and beneficiaries, such as the pitch pine type, ridgetop oaks, scrub oaks, birches, and aspen. Much of our New England forest regenerated after the '38 hurricane. Where it hit, the overstory was nearly completely removed, providing an opportunity for regenerating intolerance and also intermediate and tolerant species that were already in the understory. Not all natural disasters are over large landscapes and stand replacing. Individual and small groups of trees die, providing an opportunity for the same or another species to replace it. Gaps from individual trees are widespread and scattered throughout the landscape. Non-native insects, diseases, plants, and animals affect which trees grow in an area by slowing tree growth, killing them, and in the case of non-native plants, competing more successfully on a site, diminishing the number of native trees and sometimes completely replacing them on a given site. Here are some examples of non-native exotic insects introduced into New Hampshire's forests. An example of a human natural disturbance complex. Whether you think of them as a human disturbance or a natural disturbance, they will likely have long-lasting consequences to the makeup of our forests. Beavers are an important form of forest disturbance, and I would say a positive form of forest disturbance, especially if you're interested in wildlife habitat management. No doubt they do kill certain valuable trees along the wetlands edges, but by and large they're a positive form of forest disturbance. However, animal browse mostly has a negative impact on the establishment of trees. Deer browse is a problem in much of the Northeast. For example, Cornell University's website lists deer browse as the #1 barrier to regeneration. Statewide, 72% of the failed or marginally regenerated stand were the result of deer browse. In New Hampshire, deer browse is an impediment only in certain parts of the state, primarily along our seacoast in the Connecticut River Valley. However, in northern New England, we see excess browse from moose on some of our managed lands. Natural disturbance isn't necessarily a bad thing. It creates a diverse, more resilient forest. Here's my last topic. I want to talk about why trees grow where they do because of the inherent productivity or lack thereof of a particular site. The type of soil helps determine what types of trees can grow and how well. Soil helps determine whether a seed that lands on the ground will germinate and develop into a seedling. Soil is the water and nutrient source for the tree. Soil develops over time and is influenced by the climate and also by the parent material, the bedrock, and the deposits left by the glacier. This geology helps determine soil fertility. In addition to determine if a seed will develop into a seedling, if a tree is free to grow, soil will also determine height growth, how tall a tree will eventually be, and how fast it will get there. Certain soils favor certain trees. White ash compete well on moderate, well-drained, and enriched fine textured soils. Beech compete well almost everywhere, but especially on sandy tills. Red oak on sandy tills and outwash, white pine on outwash and sandy tills, and red spruce, hemlock, and balsam fir on shallow pan, poorly drained outwash, and shallow to bedrock soils. Conifers are adapted to competing well in pretty poor soil conditions, which is why they compete well on both very wet and very dry soils and very thin soils. By way of definition, tills are soils that are a mix of soil particle sizes and rocks deposited by the glacier. Outwash soils are sandy and gravelly and were deposited by glacial water. These soils can be drier and less fertile. A pan soil has an impervious layer fairly near the surface of the ground and holds water accessible to the roots. It can also cause challenges when logging. Soil ranges from one extreme to the next and everything in between when it comes to providing the water and nutrients trees need. Enriched soils are soils with lots of organic matter and fine particles and often are at the base of slopes. They're very productive for hardwoods such as sugar maple and white ash. On the other extreme are outwash soils, mostly sand and gravel left by the glacial meltwater. They are, however, very productive for white pine, and hardwoods have a harder time competing on these types of soils. So sugar maple, white ash grow well on rich soils, beech on poor soils, yellow birch and red maple wet soils, aspen and white birch on disturbed sites. Topography influences species composition partly because it influences soil development and partly because of the climatic influence on trees. Aspect and slope influence the amount of water available for tree growth. There is generally more water on the north-facing slopes and at the base of slopes than on south-facing slopes and on the top of hills. Elevation influences the temperature. Remember, there is a 3-degree Fahrenheit change for every 1,000 feet in elevation. Here's a nice illustration of the effect of topography on tree species. Notice the top of the north-south ridgeline in the center of the map. And hopefully, there's my pointer pointing out the ridgeline of the Monadnock-Sunapee Greenway. Here is that same area shown as a black and white aerial photo. Though the surrounding forest is mostly hardwood, as shown by the light gray color, the top of the ridgeline shows the dark color of the spruce and fir trees growing there. Spruce and fir, of course, being more northern, coal-loving softwoods that grow well in nutrient-poor condition. A perfect description for this ridgeline. I know I covered a lot about soils in a very short amount of time. If you're interested in learning more, I suggest this online publication written by Bill Leake of the U.S. Forest Service Northern Research Station, Why Trees Grow Where They Do in New Hampshire. Though I give you the web address, it will show up if you Google the title. Today, development is one of the biggest determinants as to whether we even have forests in a given area. But where forests grow and the specific type of tree growing on a site is a function of our climate, the soils, topography, our human activities, and natural disturbances. Knowing the site, the relative shade tolerance, and other concepts I spoke about, we can work to manage these forests to improve their species composition and productivity. So thank you for listening, and I'd open up for questions now.
Great. Thank you, Karen. Wonderful presentation. So before or as people are thinking about their questions, I'm going to paste the link for the continuing education credits. So if you're interested in obtaining a certificate that you can share with your credentialing organization, go ahead and follow that link. I'll send you an email within hopefully a couple of days. So there's Karen now has opened the floor for questions. And I guess I'll start with one. Could you talk a little bit more about beaver as an influence on the landscape? Do you have mean, there are places where I see them a lot, but then there are other places where you go for miles and miles and there are no beaver. So can you talk about maybe what do you know about their distribution and what kinds of impacts and how does
Sure.
it change through time? And
Sure. Well, to tell you the truth, I know precious little, but that won't stop me for trying to give you a game answer.
Please,
yeah,
go ahead.
So,
that never stopped me.
Sure. You know, beaver were nearly extirpated, or they were extirpated from the northern forests of New Hampshire, and actually New Hampshire during the trapping years of the 1800s before game management occurred and you know, trapping limits and seasons were developed. I want to say about the middle of the last century, you know, the 1950s is when we started to see beaver repopulating our state in greater numbers. And I may have the exact decades wrong, but, you know, the general outline of the story is the same. Where we see beaver is where they belong, and that's why when people complain about the presence of beaver, oh, they're killing my trees, I like to remind folks that they're inhabiting wet areas that, I mean, really wet areas that probably aren't the best for growing at least high quality trees anyways. Where they will impact high quality trees for, you know, lumber purposes is along the edges of their wetlands, but they're going to occupy fairly broad wetland complexes. So you probably won't see them in the, you know, in great numbers in steep mountainous areas. You're going to see them in those mountainous areas where there's flats, where they can dam and create, you know, their ponds. So that's where they're going to inhabit. Places where you have fairly low, broad valley situations. So that's probably more than I should have said.
No, that all makes sense.
Yeah.
And the value is, I guess, that they're going to be expanding because they create dams, they're going to be expanding wetlands that are useful to wildlife that are dependent upon those wetlands.
Sure. Waterfowl, you know, larger mammals. So they're just great wildlife habitat managers.
Okay. You also mentioned a little bit about, you talked about the regeneration of forests. Can you talk a little bit about where the northeastern forests are, if you think about kind of the big picture of forest development? I mean, do we need to be, how much do we need to be thinking about forest regeneration?
Well, I think that's where the game is in terms of, well, two things. We need to protect forests so that they remain forested, but because of that agricultural history in much of the Northeast, not just New Hampshire and Massachusetts, our forests are aging. They're at that point where if you're going to manage for a timber product, in addition to all these other great, you know, biodiversity values, but if one of your values is timber, they're at a stage where you need to be thinking of regenerating our forests. If you think of the numbers, I said that farmlands were abandoned 1850-ish on. We had a huge cycle of cutting in the 19-teens. We had a 38 hurricane. So, you know, by my count, we have forests in the Northeast or New Hampshire, and I think much of the Northeast, that are 80 years to 100 years plus. And, you know, that's, for many of the commercial species anyways, kind of their rotation age. And so we think about regenerating forests. So it's, I said in the earlier presentation today that when I started my career 30-plus years ago, we spent our time talking about weeding and thinning because our forests were middle-aged, and that is a practice that they benefited from. Now they're older and at a stage where they need to be regenerated.
In New York, we see, and you mentioned this when you were talking about deer, we see deer as a major, if not the major, barrier to successful regeneration. You said that was the case in some parts of New Hampshire. Are there other barriers that you see in New Hampshire that limit successful regeneration? I mean, when you're talking to people, what do you tell them to be alert to?
There are all sorts of barriers. Partly people's time horizons and when they need to take action might not be the best time for the forest to be harvested, both in terms of how old the forest is, but also time of year. You know, and you know, I mentioned earlier this idea of timing to meet the seed year, and also during a given year to promote scarification. So that means harvesting potentially when there's no snow. There are you can't get all the harvesting done in a given area in 2 months. It takes longer. So that's kind of a barrier to regeneration. Just the kind of the practical business end of harvesting a forest.
Okay, so we've got a couple of questions here. I don't want to monopolize all your time. Gary would like to know what conditions are responsible for the increase in red maple in the Northeast.
Sure. Well, so if you recall, red maple is considered a tolerant species, and we've spent a lot of our time focusing on making our forests look good, and people tend to like a lot of trees after a harvest. So I say we've been pecking away at our forests and just doing partial harvests and not getting enough sunlight on the ground to encourage the regeneration of intolerant, intermediate, and tolerant trees, the whole gamut of trees. And so red maple, it's a prolific cedar. It will grow where you're just doing partial harvest very well because, it will grow in that shade. And I think actually that's a big reason why red maple has proliferated. We've managed for it. We haven't meant to, but because we've been conservative often in our management, red maple has been growing.
Okay. Wayne is asking about whether single tree selection cutting will allow intermediates to regrow, so to establish and develop.
Yeah. Probably not real well. If you have some advanced regeneration that you're dealing with, perhaps. But I wouldn't target regenerating intermediate species with single tree selection by and large. I mean, we've tried to do it with eastern white pine and red oak and had some success, but usually we've already had some advanced regeneration when we've used an individual tree selection method. In New Hampshire, we're big on, we call them group selection, anywhere from a 1/4 acre in size up to 2 acres in size. So some people would say, oh, 2 acres, that's a clear cut, but it's all in the perspective and in the context. If you have a 10-acre woodlot, a 2-acre group opening, yeah, that's a clear cut. But if you have a 50-acre woodlot, a 2-acre opening, though large, isn't a clear cut, or it doesn't seem to be as obvious. Yeah.
Right. And it would depend a little bit on how you're delineating your stand. If the 2 acres is the entire stand, then you would think of it as a clear cut. If it's a portion of the stand, you might think of it as a group selection.
Yes.
So.
Yep.
Okay, Eric's picked up on your point about moose browsing and wonders how much of an issue that is.
Well, it can be quite a severe issue on a given woodlot. So moose, you know, they eat a lot, and they're very much attracted to openings. So actually one strategy for dealing with moose is to do a lot of cutting in a given area, kind of overwhelm them with food so that, you know, they don't concentrate their browsing on one woodlot alone. That's hard to do because most of us don't own enough land to spread moose browsing pressure out. But moose can devastate really, you know, an opening or a regeneration. The one thing about moose is that probably, I mean, they're very big animals, so they can browse seedlings and saplings. They're quite high, but they seem to, you know, after 10 years or so, find newer, fresher browse to feed on. So that's the one thing, is that they may be browsing a woodlot that's been harvested, but they won't browse it for 30 years. They'll browse it for 10. However, that's a fairly long time to hold back your regeneration.
Okay. Robert asks, what tree species came out the winner, either in terms of numbers or was able to fill the void following gypsy moth, and the mortality associated with gypsy moth?
Okay, well, that's an interesting point. My experience here in New Hampshire is that we've had much less mortality than you might think of. At least much less mortality of oak. Where we had mortality really was when the populations were really high. We had mortality mostly in the understory in hemlock and pine. So there might have been a period where there was sort of a gap of those species regenerating. But I'm not even sure that they would have been a target to try to bring through to maturity anyhow. So I don't know, and I can't answer that question for places that have had more dieback, which I understand probably south of New England. There's a lot more dead trees. I will say that when we lose hemlock, for example, and probably also red oak, we see black birch coming in more and more. So black birch seems to be a winner when it comes to some of these insect, diebacks. But I can't verify that for sure with gypsy moth.
So just to follow up on that, Robert Hobbs notes that in Pennsylvania they're seeing a lot of white pine coming into areas where gypsy moth had killed oak stands. Yeah, well, which fits with what you were describing as the life history characteristics of white pine.
Yeah, that's very interesting to me. I mean, I'm not sure what the situation is with gypsy moth in Pennsylvania, but basically our gypsy moth is kind of in endemic levels and have been in endemic levels. In other words, just sort of a low level population of them since the last outbreak in the 1990s. And that was a fairly small outbreak. Our last really big outbreak was in 1982 or 3. So we haven't been focusing our worry and concern on gypsy moth. Our forest really recovered very well from it. One of the biggest impacts of gypsy moth defoliation, however, was lower grade of oak, for example, because we had a lot of epicormic sprouting, or like water sprouting along the trunks of the trees, and that degraded the quality of the lumber.
I suspect the phenomenon, or the phenomenon of response would depend a bit upon the abundance of oak to start with. So what you're describing in New Hampshire was sounds like fairly scattered oak. which if you had just single tree gaps, you would have one kind of a response. If you had oak forest where oak was 70 to 90% of the stocking, then you would have a different response.
You have to understand, when I say I'm working in an oak stand, if I even approach 50% stocking of oak, that's huge. Our oak stands are really mixed, intermingled with sugar maple if it's a higher quality site, or pine, hemlock on the drier site. So we don't grow oak stands like parts of Pennsylvania and New York grows oak stands.
Mm-hmm. Yeah. Okay. Bill is asking, he's I guess first clarifying that there's going to be a significant loss of ash and hemlock, and then assuming that, if you'd like to comment on what the long-term change in the forest is going to be.
Sure. Well, we can guarantee that there'll be a significant loss of ash. Emerald ash borer kills trees infested by it within 3 to 5 years, unless it's a shade tree that you're protecting with some sort of insecticide, and then that's not going to happen on our forest, because the insecticides that are most effective and safe are systemic insecticides. They're not foliar application. So, like with gypsy moth, actually, we did, 30 years ago, do some aerial spraying of Bacillus thuringiensis, for example, and some other products. But so we won't be able to treat ash trees, and they're going to die in the forest, die and or be harvested. The question related to hemlock, we are just starting to see some hemlock die back from hemlock woolly adelgid, and we've had it in our state since I think 2000, 2001 was the first time we saw it. So what our entomologists hope and think is that the colder weather, while it won't out and out kill hemlock woolly adelgid, it will keep knocking it back, so that hemlock hopefully will have time in between higher populations to recover and rejuvenate. So far that's been our experience. But so while I agree ash is a goner, at least in the northern forest here, maybe hemlock won't be quite as the situation won't be quite as dismal. Having said that, again, I mentioned black birch earlier. I think that'll be the winner with regards to hemlock. At least that's what they've seen in Connecticut. Increase in the growth of black birch, which, by the way, I think is an underappreciated and underloved species. It's a fast-growing tree, beautiful lumber, beautiful wood, same wood characteristics as yellow birch and paper birch. So I don't know if I answered that question very well for...
I think you did. And,
okay.
and I think you also maybe through that answered Suzanne's questions about what's going to regenerate in the following. So it'd be black birch, which in parts of New York, we don't think of black birch with such regard. So,
you don't like it?
Well, we have problems with nectaria canker.
Oh yes, that can be an issue.
And some of it is just that we don't have the markets, and when there's been good markets, I mean, we've sold on one of the Cornell properties, we've sold black birch stumpage as firewood, and the logger was connected well enough. He sold it as veneer. It went up to Maine. So good for him. He's got one past us.
You have to be careful about what you say about black birch, because it's my favorite tree.
Okay, all right.
Okay.
Well, I tried to qualify that. I don't want to upset you with.
Okay. It's 100% an aesthetic reaction. I love the way it looks in the winter against the sky.
Okay. So. Good.
Yeah. Yeah.
Well, it looks like the questions have have concluded. So with that, I want to thank Karen very much. She gave 2 fabulous presentations. Both of them were recorded, and I will upload one of these to the YouTube site. So for those of you that maybe, give me just a second here so I can type. So Forest Connect has a channel on YouTube, and all of the former previous webinars are archived there. So if you want to go back and review old editions, it's great entertainment and education. So I encourage you all to go there. So thank you all very much. We'll call this to a close, and I wish you all a great evening. The next webinar is going to be the 3rd Wednesday of March, which is also the 18th. And if memory serves me, we'll have Ben Spong, who's a forest operations specialist from West Virginia, talking about forest harvesting systems. So thank you all, and have a great evening.
Okay, good. Thank you all.
Great
Goodbye.
job, Karen. Thank you.
Yeah, thank you, Peter.